So after learning the anatomy of polynomials, which is kind of how to name them and classify them, we're going to get into kind of operations using them. So the first one today is going to be adding and subtracting polynomials. Standard form of a polynomial. This is important. Usually a polynomial is written with all the exponents in descending order, which is largest to smallest. When we add or subtract, we put all our answers in standard form. And here's an example. It's in descending order from exponents. Two polynomials can be added by combining like terms and putting them in standard form. So the first one, my biggest exponent is x to the fifth. So I have a plus 2x to the fifth and a minus 9x to the fifth. So a little bit of mental math if I do it on the side. You have a 2 minus 9, which is just a negative 7. So far I have a negative 7x to the fifth. Then I'll look for the next one. Let's go new color. Anything to the fourth. I don't have anything to the left, but I do have this 2x to the fourth. So I'm just going to bring that down. Then I look for the next one. I have a 1x to the third and a negative 2x to the third. It's a little bit of side math. 1 plus a negative 2 is a negative 1. So I have negative x to the third. Then I go x squared. Negative 7x squared. 12x squared. That gives me 5. So that's going to become a 5x squared. Then just a regular x, I have 5x plus 3x. So that will give me 8x. And lastly, my constants. Negative 7 and a negative 9. That's going to equal negative 16. And it's in standard form. Therefore, this is my answer. Two polynomials can be subtracted by combining like terms and putting them in standard form. Now we're going to get into subtraction. But you must remember that everything in the second parentheses is subtracted. Many people find it easier to do this by changing the minus in the middle to a plus and then changing the sign on everything in the second set of parentheses. I want you guys to do this method every single time. So I'm going to kind of set this one up for you so you can see it. It'll just be easier in the long run to kind of show me that you understand what's going on. So what's going to happen is that this is going to become a positive, and every single one of these will change their signs. Let's kind of show that. This stays the same. This will become a plus negative 12x squared, negative 2x to the fourth, plus 2x cubed, minus 3x, plus 9, plus 9x to the fifth. And I'm going to do the same thing as the problem above. Find my matching terms. 2x to the fifth, 9x to the fifth. You add those two together, and that gives you an 11x to the fifth. Negative 2x to the fourth, that's the only one. X cubed plus 2x cubed. I'm at 3x cubed Negative 7x squared minus 12x squared. That's a negative 19x squared. 5x, negative 3x gives me a positive 2x. And lastly, my constants, negative 7, positive 9, that gives me a positive 2. So this is your answer. The next one says, what polynomial would you subtract from 17 minus 7x to the 5th plus 12x to the 5th minus 33x plus 32x squared to get a difference of a negative 9x to the 5th plus 6x to the 7th plus 30x squared minus 15x minus 3. So now we're going to kind of find that missing piece. And what I'm going to do is I'm going to change the standard form. Let's make a note of that. Change to standard form. And then line up vertically. So the top one in standard form becomes 12x to the 7th minus 7x to the 5th plus 32x squared minus 33x plus 17. Then I get minus, this is where the kind of blank comes in, minus, I have a something x to the 7th, a something x to the 5th, something x squared, something x, and something. And that's going to give me an answer of what we have above, 6x to the 7th minus 9x to the 5th plus 30x squared minus 15x minus 3. So notice that these were lined up. I have x to the 7th, x to the 7th, x to the 5th, x to the 5th. So that's what I mean by lining them up. And we're going to kind of just think of this like individual problems. The first one's going to be this. So that line there. And really what I'm going to think about is this. 12 minus 12x to the 7th minus what equals 6x to the 7th. And my answer is a 6x to the 7th. Because 12 minus 6 is 6. Then I'm going to look at the next one. So let's kind of just do this so we know. Negative 7x to the 5th minus what equals a negative 9x to the 5th. And the answer is going to be a positive 2x to the 5th. Because if you subtract, don't forget the subtraction here, 2 more, then it's going to become a 9. That's this color. Next one. $32x squared minus what equals 30x squared. If you guessed 2x squared, you are correct. Then we get a negative 33x minus what equals a negative 15x. Now here's a tricky one because it's going up, which means I'm going to have to add a negative in here. So that way it becomes a double negative. And so my answer would be negative 18x. Because negative 33, this would become a plus 18x, would give me negative 15x. And lastly, 17 minus what equals a negative 3? And my answer is 20. So my final answer is this here, which is 6x to the 7th plus 2x to the 5th plus 2x squared minus 18x plus 20. And the last one. The number of women enrolled at a local college can be modeled by the polynomial blank, where t is the number of years since 1950. The number of men enrolled in the model can be the polynomial blank. Find the model for the total students enrolled. You're just going to add the men and the women. I'm going to take the women one. And I'm going to add it to the men's. Notice how I'm just stacking it. And I add down to give me an answer of 2,387.61 t plus 155,220.46 total students. Find a polynomial model for the difference between the number of women and the number of men. So difference would mean you're going to go women minus men. Difference means to subtract. So I'm going to line them up again. And I'm going to go ahead and do this. Don't forget, when you subtract, just change all the other signs to the opposite. So this would be a negative, and this would become a negative. And so now when I do the difference, I get an answer of, I'm going to write it over here, 59.55 t plus 3,975.60. That is more women than men. And the last one. Use your answer for part A to determine the number of total students enrolled in 1990. So, if the equation above said this was 1950, and now we're trying to find 1990, how many years is that? You would do 1990 minus 1950. See that I'm plugging in 40 for the number of years. So I'm going to plug in 40 for t. If my equation was 2387.61 t plus 155,220.46, I can replace t with 40. I solve to give me an answer of 250,725 total students enrolled.